Good morning. We are from Group 1 and we are going to present about the atomic absorption spectroscopy. The aim for this project is to know the importance of atomic absorption spectroscopy in analytical chemistry. So in this project, we are going to explain about how to use the atomic absorption spectroscopy. So there are four objectives in order to achieve the aim, which are to understand the use of atomic absorption spectroscopy, to study the methods used to identify heavy metals. So for this one, we are going to use the results for to find what are the what heavy metals are there in the herbal drugs, contained in the herbal drugs. So third is to study the existence of heavy metals in herbal drugs. And last is to understand the necessary heavy metals required in human bodies from herbal drugs. Okay, so this is what atomic absorption spectroscopy looks like. So atomic absorption spectrometry detects elements in either liquid or solid samples. For example, a miner, they want to find out what element contains in a rock. So they need to find out what elements are there in a rock to know if whether they can proceed the mining or not. So this is what basically AAS functions. So as for background, I am going to do a summary based on this paragraph. So this is Robert Bunsen and this is Gustav Kirchhoff. They both made a conclusion that in a vapor phase, each element has its own unique spectrum. And then this Kirchhoff state that at a certain wavelength, a material can emit radiation, and that wavelength it can absorb radiation. So AAS is not used widely in analytical technique, but Bunsen and Kirchhoff, they decided to make a big step to define the technique of AAS, atomic absorption spectroscopy. There are many applications for AAS, atomic absorption spectroscopy, but I'm going to list out three only. So first is this is a picture of pharmaceutical, and this is agriculture, and this is forensic. So first application is to determine percentage of heavy metals in herbal drugs. So this is what the project is basically about. And the second is identify and analyze the presence of potentially harmful elements in the environment. So, and then the last one is to analyze blood samples, brain and muscle tissues, and gunshot powder residue. So there are advantages and limitations of AAS. So the first advantage is that it is inexpensive. The reason is because it uses less argon than other method, so it costs less. And then the second is high precision. So the precision here is based on the accuracy of the results. where it normally have a rate of 0.5 till around 0.5 until 5%. And it can get a better rate if appropriate standards are being used. So the third advantage is it is sensitive. It has a sensitive method of detection. AAS can measure down to parts per billion of a gram in a substance. So it has a very sensitive detection. Last is it can reach inaccessible places. The reason is because it relies on radiation and light absorption. Next is the limitation of AAS. So its first limitation is the precision. Just now the advantage, it has high precision based on the accuracy of the result. So for this limitation, the precision is basically based on the interfering of other chemicals that are found in the sample or the surrounding of the lab. So it can interfere the results of the study. Second limitation is the equipment. The equipment it's expensive, so they cannot use the equipment for a widespread use in a lab because it's it's much more expensive, but it is more portable than the previous instrument. So the third limitation is that it lacks of versatility. So most of the AAS practices, they focus more on liquids than solids. This is because the substance has to be vaporized first before it can uh, be analyzed.
Thank you to Valerie for the presentation on the introduction. My name is Nurshahada binti Abu Wahab Hashim, and my metric number is 72568. So I will be presenting the description part, which basically comprises the theory, description on the working principle of AAS, and so on. According to Raja and Baron, prior to understanding the theory of AAS and its mechanism, it is crucial that some information on its background is grasped. As can be seen here are the revolution of atomic theory which are essential in the AAS process, contributed specifically by John Dalton, Niels Bohr, Louis de Broglie, and Wolfgang Pauli. I will not go through these discoveries, but it should be noted that these breakthroughs of atomic theory are crucial in understanding the workings of AAS, especially the one which is brought up by Louis de Broglie, that is regarding the energy quantized electrons. Moving on, when atoms are exposed to radiation, they become excited, and this in turn will result in the creation of absorption spectrum. As the atom gets excited, the valence electrons which are placed in the outermost shell will move up an energy level. Therefore, from the emissions line, energy for varied stationary states as well as restricted orbits can be established, and this particular radiation which is being absorbed in order to attain the excited state is called resonance line. As proposed by Planck, energy coming from the radiation is emitted in quanta and can be associated with the Einstein equation over here. So from the combination of these two equations, an equation which accounts for the frequency of radiation, V equals to C over lambda, is derived, and as a result of the quantized energy level, only specific wavelengths are permitted and every atom has special spectrum of their own. To better understand this, Let's take an example of a sample which consists of copper. So when this sample is exposed to light alongside other elements such as zinc or iron, if this sample is exposed to if this sample is exposed at a specific wavelength for copper, the light will only be absorbed by copper atoms, and this applies to other elements as well. So in AAS, there are two atom cells, namely flame atomic absorption spectroscopy and electrothermal atomic absorption spectroscopy. So as can be seen in this two figure over here, in an atomic absorption spectrometer, there are many components such as the light source, monochromator, detector, and so on. So each of these components will be discussed briefly in the following section starting from the light source. In AAS, there are two types of light source that can be used, namely hollow cathode lamp HCl or electrodeless discharge lamp EDL. Among these two, HCl is used more often than EDL, and in this presentation, I will be presenting the mechanism of HCl only. So the cathode of HCl is coated with analyte of interest, and the lamp is filled with inert gas such as neon or argon that is kept within the pressure of 1 to 5 torr. The inert gas will be ionized when the electric current is applied and will consequently be attracted to the cathode as they are accelerated into the direction of the cathode. The metals ion which caught the cathode are excited um, as the inert gas ions bombarded the cathode. As a result, radiation with characteristic wavelengths of analyte interest is emitted, and there are a few requirements in which a light source should fulfill. Firstly, it should be able to provide a profile of narrow lines with little background as well as the ability to produce a stable output. Other than that, it should also be reproducible with sufficient intensity. These requirements basically ensure that a high signal to noise ratio can be obtained. In AAS, source modulation is essential so that the component of radiation which arises from light source or flame background can be differentiated. Therefore, modulator or light chopper is needed. So how does this work? As the chopper rotates, an alternating atomic absorption and atomic emission signal is produced. Therefore, at one moment where the light from the light source is cut off, only light due to the flame emission can be read. Then, the next moment where both lights are allowed to pass, both lights can be read. Next is the atomization system. Among the many steps in AAS, atomization is the most crucial step. Why so? This is because the sensitivity of the reading is determined in this step. The two most commonly used atomizers are flame atomizer and electrothermal atomizer. Flame is a discrete atomizer and electrothermal is a continuous atomizer. Here are the schematic representation of the atomizers, and both of these atomizers have their own advantages and disadvantages. However, flame atomizer is more preferable for its simplicity and cost effectiveness. And as for the atomization system, I will be focusing on the explanation for flame atomizer. So let's go back to the schematic diagram of AAS for this explanation. So once the solution is drawn in through this tube over here, they will be taken to the nebulizer, and the aerosol from the nebulizer will be carried to the atomizer, and as they reach the flame, a sufficient energy is gained to volatilize and atomize the sample. Line isolation, on the other hand, ensure that only light of the characteristic wavelength of an element is being measured. The device used in the isolation is the monochromator, and monochromator itself has many designs, and the three most common designs that are used are the Cherney-Turner, Ebert-Fosty, and Littrow configuration, which have advantages and disadvantages of their own. Next is the detection system. So a detector is placed in front of the output slit over here, wherein it receives photons specified by monochromators. So Older equipment uses photomultiplier tubes, PMT, as can be seen over here, and modern equipment uses solid-state detector type CCD coupled charge device. In general, the detector works similarly despite its configuration. So now I will briefly explain on the workings of PMT. It gains light through the window which encloses the photocathode that will emit electron. So as the electron is emitted, they will be accelerated toward the dynode and amplified successively. So as can be seen here, the electrons are amplified as it moves from one dynode to another dynode. And then the electrons will then be collected as current and converted as voltage to be measured. Lastly is the data processor. Nowadays, with the development of computers and programs, data processing and instrumentation control can be done and assessed more easily by computers. With the specific programs equipped, a lot of things can be done, such as to program the number of automatic sample as well as the calibration curve and so on. Okay, now that each component has been explained, I will summarize the general principle and mechanism of AAS. AAS is a common analytical tool which is used in measuring the concentration of an element. It utilizes the characteristic wavelength in which an element absorbs. So, as a sample solution containing analyte of interest is introduced into the instrument, it undergoes atomization, wherein the sample is converted into gaseous atoms. Some of the atoms are excited and will emit electromagnetic radiation, which passes through the vaporized sample, and this in turn enable the atoms to absorb the radiation which has been emitted. According to the Royal Society of Chemistry, the number of atoms is proportional to the quantity of light being absorbed or vice versa. Therefore, the greater the number of atoms in the vaporized sample, the greater the absorption of radiation. Then, the concentration of analyte of interest in the unknown sample is determined by comparing the amount of standard absorbs with the calibration curve. How is this calibration curve obtained? It can be obtained by running a few samples of known concentration of the element under the same conditions as the unknown. So that is all for the description. The next part, which is methodology, will be covered by Shadi.
And for methodology, I will be explaining the standard procedures of conducting atomic absorption spectroscopy. Okay, first of all, this procedure is based on heavy metal detection in herbal drugs by using AAS experiment. So the apparatus needed for this experiment is electrical balance, digestion tube, 500 microliter automatic pipette, volumetric flask, beakers, grinders, water bath, and Shimatsu 6300 AAS. The materials needed for this experiment is dried herbal drug sample, which is taken from 3 different zones from Karachi cities, and there are 7 samples in total, so we have 21 samples. Analytical grade nitric acid, 70% perchloric acid, deionized water, distilled water, Whatman filter paper, and standard stock solution to test for the heavy metals. Okay, first of all, we will prepare the sample by wet digestion method. First, we have dried sample of each drugs, pulverized twice, and turn into finer state of powder by using grinder. And then next we wet 1 gram of each dry sample powder by using electrical balance. And then next 10 milliliter of concentrated nitric acid is added to the beakers. And the mixture is left to stand overnight. Next, the solution is heated in water bath until production of red nitrous oxide fumes has stopped. And then the solutions were left to cool at room temperature. Next, 4 ml of 70% hypochloric acid is added to the previous solution. and heating is done once again to evaporate the solution to a smaller volume. Before the sample can be used for AAS, the solution is filtered by using water filter paper and transferred to a volumetric flask, and distilled water is added to dilute the solution. After wet digestion preparation for the sample, we can proceed to AAS measurement by using atomic absorption spectrophotometer Shimatsu 6300. So first of all, we will prepare 250 milliliter of the deionized water and transfer to 5 dry beakers. And then automatic pipette is used to transfer 0.0, 0.5, 1.0, 1.5 and 2.0 milliliter of lead stock solution to the beakers and mix well. The concentration is calculated and recorded. Next, we can proceed to flame atomic spectrophotometer is set up by referring to the operating instructions which I will explain later. After that, we can repeat this step, second step, by changing the stock solution to other elements that we are testing. Data obtained for the measurement for each element is recorded and tabulated, and then the obtained data will be discussed in result and discussion section. So this is the software used to conduct AAS, which is called Wizard. So basically, these are the flow chart of using Wizard software. First, we have element selection, and then calibration curve parameter setting, sample parameter setting, and lastly, spectroscope parameter setting. So this is the procedure used to set up the software. First, we check the water level in waste jug. Prepare waste jug. Spare waste jug if the water is more than half full. If it is 3/4 full, you must change the water. Next, turn on the computer and launch the wizard program. Choose the reset template tab and select experiment 5 AAAE TAA. And then next we have element selection. We can choose what element we are testing in the experiment in the software. And then next we switch on the AA, which is the Shimatsu 6600. The power switch is at the front lower right of the instrument. Next, you click Connect Send Parameters button. Initialization checklist will be shown and safety parameter test will be asked. For this parameter test, you choose No because the laboratory might have done the parameter test weekly. And then next, we have instrument checklist for flame analysis. For this screen, you will have to inspect all the items and check them off before you can start using the instrument. Next, turn on the airline using orange valve located nearest to the regulator. The value of the airline must be set from 40 to 45 psi. And then you open the tank valve on the top of the acetylene by turning it 1.5 rotation. When you have done with the checklist, click OK. Next, connect to instrument send parameters. Click Next for this screen, and then you will see the optic parameter screen. Click on lamp on box to switch on the lamp, and then click Next. And then you will see the program will ask you for line search or beam balance is necessary. For this ask box, you click OK. After the line search has finished, spectrum will appear with red line crossing at the maximum. If you see the red line is not at maximum, run the line search once again. Click Close when it's done. And then you will see another pop-up screen which show atomizer or gas flow rate setup screen. Next, you will have to make sure that the burner is in the correct orientation, which is perpendicular or parallel. Next, before you can proceed with the experiment, you will see two buttons labeled ignite on the front panel of the instrument. Press and hold both buttons, and then you will hear air flowing. Flame will ignite after 5 to 10 seconds because you are conducting flame atomic absorption spectroscopy. And then after 5 to 10 seconds, you will see absorbance level on the chart will increase after the flame is ignited. Next you have to make sure that the burner height or gas flow adjust is on the screen, okay? And then verify that the burner height is optimized by moving it up and down by using computer control. And then click finish. After finish, you can conduct data collection. So this is the interface or the screen of the Wizard software. So this is where the chart shows the elements and the signal. So this one is for calibration curve. This one is real-time signal monitor. And this chart, it looks like Excel and also work like functions like Excel, which is called as MRT or measured result table. From here you can get many information such as sample name, absorbance, concentration, and other results that are needed. Next, I will explain about data collection from Wizard software. For data collection, first the suction tube is placed in the DI water. So make sure to observe the absorbance versus time plot in the upper left corner of the screen. When you see the absorbance level has stabilized, the button auto zero is clicked. And the next suction tube is placed in the zero concentration standard. Blank button is clicked after the absorbance level has stabilized. Next, absorbance of standards solution and the drug sample is measured according to the rows in the MRT. To perform this, you put suction nozzle in one of the solution and let to expire. Click the start button once you see the absorbance level has stabilized. Then the instrument will start after 5 seconds. We will wait after 5 seconds, and after that it will collect data for another 5 seconds. The results can be seen in the MRT. To turn off the instrument, uh, we press the extinguish button, and then main tank valve of the acetylene is closed. Next, line of acetylene is purged by pressing the purge button, and then you can see the orange air valve on the wall, and that valve is closed. Power to the AA is turned off, and lastly, exit the program. So these are the few precautions that students or any practitioners must remember before handling AAS. First, when switching elements for the analysis, such as, for example, from lead to cadmium, start over the measurement from step 8 before. And it means the experiment is repeated from the line search or beam balance step, and burner height must be done again when you change the standard. Next, always add the nitric acid to dried sample to allow digestion to occur before adding perchloric acid, because perchloric acid reaction with untreated organic matter can cause explosion. So this is we must take extra caution. And then next, do not lift without closing the acetylene tank because acetylene is explosive and dangerous. To export data, select File and then File Export. The exported data you can view in Excel program. And to turn on the burner, oven door is open and the burner is turned using its arm.
Okay, I will explain to you the results and discussion for the atomic absorption spectroscopy. As you can see here, there are 7 types of herbal drugs based on the journal. The first one is Glycyrrhiza glabra, where we call it as G. glabra, and this is O. bracteatum, B. odorata, E. vulgare, C. cyminum, C. sativum, and Z. officinalis. The name shown here is the family name for each species of these herbal drugs. Generally, there are two types of heavy metal, which are the essential heavy metals and the toxic heavy metals. The essential heavy metals consist of copper, zinc, chromium, nickel, cobalt, and iron. Meanwhile, for the toxic one is lead and cadmium. This toxic metal is not necessary in human body as it might cause harmful once human consume these herbal drugs that contain high level of toxic metals. Okay, the graph shown here is the concentration of heavy metals that are present in G glabra and orbit data mole from three different zones consist of zone A, zone B, and zone C after it was being tested by using the atomic absorption spectroscopy. The data shown here is the highest level of zinc contained by the G glabra from zone A. The concentrations for the zinc metal here is 433.76 microgram per gram. Besides, there is also presence of toxic metal in these two herbal drugs, which are the PB metal and the CD metal. The data showed that there is a highest level of CD metal in zone A. Meanwhile, there is also presence of a maximum level of PB contained from zone B. The concentrations for this PB metal purchased from zone B in orbit datum is 4.91 microgram per gram, and the concentrations for this PB metal has exceeded the permissible limit that has been given by the WHO, which is known as World Health Organizations. And also, there is presence of copper. There is also presence of highest level of copper in G glabra that is obtained from zone C after it was being tested by using the atomic absorption spectroscopy. And the concentration here for the copper one is 120.21 microgram per gram. And besides, there is in terms of nickel, there is also the highest level of nickel in Olbrecht-Tatum plant compared to G glabra plant. The concentrations for this nickel here that is obtained from zone B is 76.97 microgram per gram. The figure shown here is the concentration of heavy metals in V odorata and F vulgare, which is come from zone A, zone B, and zone C. And as you can see here, there is a higher level of zinc in these two herbal drugs. However, the highest level of zinc is in V odorata, which is purchased from zone B. And in terms of CR, the maximum concentrations of CR here is in V odorata, which is from zone B, where the concentration is 186.75 microgram per gram. Meanwhile, for the minimum concentration one comes from F vulgare, which is from zone C, where the concentration for the CR metal is 1.61 microgram per gram. The empty part here is the value for the Cu metal. However, as you can see here, this is empty, so there is no presence of Cu in three different zones of F vulgare plant. In F vulgare plant, there is also presence of toxic metal here, which is this one, the Pb and the Cd metal, and it shows the F vulgare, which is come from zone C, has exhibited the lowest concentration of Pb, which is 3.26 microgram per gram. Meanwhile, the highest contaminations of the Cd metal is 4.89 microgram per gram, which is obtained from zone A. The figure shown here is the graph for the concentration of heavy metals that are present in these three herbal drugs, which are the C. saninum, C. sativum, and Z. officinalis, that are collected from three different zones. As you can see here, there are presence of the PB metal here in these three different zones, where the concentrations for the C. saninum is from 0 to 28.92 microgram per gram, Meanwhile, for the C sativum is 17.85 to 24.32 microgram per gram, whereas the Z officinalis, the concentration of the TB metal that is detected in these three different zones is 13.13 to 22.63 microgram per gram. The contaminations of the TB is significantly higher in C. seminum, which is come from zone A and zone B, here, this one, and the contaminations of CD in Z. officinalis is almost the same with the concentrations of the contaminations of CD in G. glabra, where the concentrations for this one, for the CD1 is 1.63 microgram per gram. However, this empty space here for the C. sativum and the C. seminum, this one, this is the symbol for the CD. So this empty space shows that there is no presence of CD metal detected when it was being tested by using the atomic absorption spectroscopy. Apart from that, the highest level of zinc obtained among these three herbal drugs is in zone B from C. sativum, as you can see here, the highest level. And then the lowest level acquired is by the zone B of Z. officinalis, this one, with a concentration of 83.74 microgram per gram. And the C. seminum is purchased from zone B, this one, is showed the minimum contaminations of nickel, which is 0.48 microgram per gram. It is too small where it does not show in the graph, but the concentrations for the nickel is 0.48 microgram per gram. However, it was analyzed that there is no contaminations of nickel that is present when it was being tested by using the AAS, and both the C. seminum and the Z. officinalis that comes from zone B showed the highest level of cobalt. This one, it shows the highest level of cobalt metal. The concentrations for this one is 77.44 microgram per gram. Meanwhile the cobalt contained in Z. officinalis that procured from zone C is 77.97 microgram per gram, where these two concentration is almost the same. The bar graph shown here is the comparisons for the concentrations of iron metal that is present in these 7 types of herbal drugs consists of 3 different zones. And as you can see here, there is a presence of the highest contaminations of iron, which is the G. glabra in zone B. The contaminations of iron here is around, it is 1652.89 microgram per gram. The second highest is followed by the concentration of iron in C. sativum, which comes from zone C. The concentrations, the iron contained here is around 1600 microgram per gram, which is almost the same with the concentration in G. glabra. These two showed almost the same concentration for the obractatum and F. vulgare, where the concentration here is around 600 microgram per gram. However, the minimum iron content among these 7 types of herbal drugs is Z. officinalis, which was obtained from zone B and zone C, these two. And the concentrations for the iron contained in these herbs is 65.68 microgram per gram. Okay, before I discuss more about these 7 types of herbal drugs, generally, the presence of heavy metals like the essential metals and the toxic metals is one of the factors that affect humans' health. The long-term exposures of these metals, the essential metals and the toxic metals, especially the toxic metals, it might lead to health risks or health problems because some of these heavy metals acts as a toxic to all living organisms. once they consume these herbal drugs. As you can see here, this is the picture for the G. glabra. G. glabra, also known as licorice, and the part used in G. glabra is roots. This one is roots and the rhizome parts, which these two is always utilized as a folk medicines. Licorice root is a traditional medicine used mainly for the treatment of peptic ulcer, hepatitis C, and pulmonary and skin diseases. Based on the result, as what I mentioned before, there are presence of the toxic metal in G. glabra, which are the Pb metal and the Cd metal. Based on the results, the concentrations of the Pb, Cd, and Cu in these herbal drugs is for the Pb 9.72, 22, 26.11. Meanwhile, for the CD contained in this G. glabra plant is 1.63 microgram per gram, and the concentration, it has exhibited the maximum concentrations for the Cu metal in G. glabra, where the concentration shown here is 120.21 microgram per gram. These three concentrations for the Pb, Cd, and Cu metal has exceed the safety limit, where the safety limit for the Pb is 10 milligram per kilogram, while for the Cd is 0.3 milligram per kilogram, meanwhile for the copper metal is from 4 to 20 microgram per gram. It has exceeded the safety limit that have been set by, or that have been given by the World Health Organizations, which is also known as WHO. However, there is the high level of Pb contained in this herbal drug might lead to colic, anemia, chronic nephritis, headache, and so on. However, the concentrations of the essential metals like the zinc, chromium metal, nickel, cobalt, and iron are below the prescribed limit that have been set by the WHO. Therefore, the low contaminations of heavy metals in G. glabra cause them to be an adequate source of these essential metals. Okay, meanwhile, the picture shown here is for the obertatum wall. The part used in this herbal drug is flower. The flowering part is used to cure the rheumatism, ulcerative, diuretic, as well as the heart diseases. This herbal plant is being contaminated with the toxic metal, which is the Pb and the Cd metal, which caused it to be dangerous or to be harmful when it was being consumed by the human. The level or the concentrations for the Pb and Cd, which was obtained from zone A, are 21.3 microgram per gram, and for the CD1 is 4.91 microgram per gram. Both of the essential heavy metals and the toxic metals are transmitted or absorbed by the soil through roots, or even from air. It comes or it flows through the dry or wet depositions. This medicinal plant will become uncontaminated plant when the heavy metals are exhibited or contained at a low concentration, as well as when the herb is constantly being exposed to the environmental pollutants. Besides, the contaminations or the concentrations for the Pb from which comes from zone B is at maximum, as I mentioned before. The concentrations for the Pb in zone B is 30.46 microgram per gram. This clearly shows that the intake or the consumptions for these herbal drugs, the obractatum, is totally not safe due to the intoxications of heavy metals that is contained by these herbs. Okay, the picture shown here is the picture for the V. odorata. As you can see, it clearly shows that It is the Biodorata is a species of a flowering plant where it is usually with a dark violet color or the white color. The part used for the therapeutic uses in this Biodorata is a flower, where the flowering part, where this is the um, functions of the flower in Biodorata. This herb also act as an expectorant, diaphoretic, antipyretic, and so on. However, the range there is a presence of the toxic metals that are present in this Biodorata. The concentrations or the range for the Pb metal contained by this herb is 9.59 to 21.11 microgram per gram, where it is significantly greater in zone B compared to zone A and zone C. Moreover, the high concentrations of Cr, as I mentioned before, the high concentrations of the Cr metal, which was obtained from both zone A and zone B, caused the elevated of the toxic level. Based on research, the high concentrations, the inhalations of high levels of the CD metals or the Cr metals causes the irritations to nose, for instance, the runny nose, nosebleeds, ulcers, and also holes in the nasal septum. The ingestions or the intake of the high levels of the of the Cr metal can cause the stomach upsets, ulcers, convulsions, kidney and liver damage. Furthermore, it also can cause death once people consume it um, at the high at a high concentrations. The chromium metal is known as a human carcinogen. Okay. The heavy metals like the Cu, zinc, nickel, cobalt, and iron were found that when it was being tested, these heavy metals um, were under the prescribed limit, which has been set by the WHO. Okay, this is the picture for the F. vulgare plant. The F. vulgare plant is also known as fennel, where it is a flowering plant. It is also known as it is also known as the species of the carrot family. The part used in this F. vulgare plant is fruit. The fruit part is used to cure the mild spasmodic gastrointestinal complaints, bloating, and flatulence. Besides, it has reported or the it has reported that the essential oil is also used or is also can it can be used as a medicinal purposes in the pediatric colic and some respiratory disorders. The Pb and the Cd contained in these herbs are 29.05 microgram per gram for the Pb metal, and for the Cd metal, the concentrations is 4.89 microgram per gram. However, in zone C, the contaminations of the Pb is at the lowest concentrations, where the concentrations for the Pb here is 3.26 microgram per gram. The presence of this toxic metal will give rise or due to the intoxications of the Pb and the Cd metal because it might cause harmful once humans consume these herbal drugs. Okay, this is the picture for the C. seminum part. As you can see here, this is the seed for the C. seminum, and it is kind of a flowering species. The part used in the C. seminum is the seed, where the seed is quite effective um, for the medicinal purposes as it is function to cure where the function of the seed in C. seminum is to cure the common cold and stomach diseases. Based on the results, as I mentioned before, there is the empty parts based on in the graph. shows that there is no contaminations of CD is detected when it was being tested by using the atomic absorption spectroscopy. However, the PB contained in zone A and zone B is it has exceed the prescribed limit which was given by the WHO. The range for the PB metal here is from 0 to 28.92 microgram per gram. The other heavy metals such as copper, zinc, cobalt, nickel, and iron are found that it was under the prescribed limit that have been set by WHO. Thus, it can be concluded that cumin is, or the C. seminum is proven to be relatively secure and generally non-toxic, even ingested at maximum doses. Okay, the picture shown here is the species for the C. sativum. The green one here shows the fruit part for the C. sativum. The part used in curing, the part used for the medicinal purposes is fruit, and the sesativum fruit is quite useful for human consumption in treating their health problems because the fruit parts have carminative, diuretic, tonic, and so on. The intox and based on I explained before, as I mentioned before, there is no contaminations of CR is found in C. sativum. However, there is presence of this toxic metal, which is the PB metal, where the concentrations for this PB metal in C. sativum is in the range of 17.85 to 24.32 microgram per gram. The presence of this toxic metal caused the toxicity of the PB metal in C. sativum to be increased. However, all the essential metals, like I mentioned before, the copper, nickel, iron, and so on, were below the prescribed limit that have been set or that have been given by the WHO. Thus, it can be said that this C. sativum is quite useful for human in curing or in treating their health. Okay, this is the picture for the Z officinalis. I think this is too common because everyone is using this for culinary. So this Z officinalis is one of the top worldwide consumptions for the culinary and for the therapeutic purposes. Um, this Z officinalis, the part used in this Z officinalis is at the rhizome part, where this rhizome part is used for the treatment of colds, digestive maladies, fevers, and so on. The toxic heavy metals like the Pb and the Cd metal were detected when it was being tested by using the atomic absorption spectroscopy, and it was found out that the contaminations for the Pb metal present in these herbal drugs is in the range of 13.13 to 22.63 microgram per gram, as I mentioned before, in the result part. And the concentrations for the CD contained in this Z officinalis, which was obtained from this zone B, is 1.62 microgram per gram. And this, however, based on the results shown before, there is no presence of copper and chromium ion is detected in these herbal drugs. And then the essential heavy metals are analyzed, and it was found out that these essential metals, like the copper, nickel, and iron, and so on, were under or were below the permissible limits, which was set by the WHO.
From here, we can see that each element's atoms absorb a certain radiation frequency that is unique to that element. So the amount of absorption is determined by the concentration. And then, therefore, most of the herbal drugs that is sold on the local herbal markets are toxic and unsafe for human consumption. So by using the atomic absorption spectroscopy, we can determine the amount of heavy metals in the herbal drugs. So especially PB and CD due to high levels of heavy metals. That is all from us, Group 1. Thank you.